Welcome here from Switzerland, from where I will give the next two presentations. So the first one is about new things that happened in the last two versions of Mathematica 13.1 and the upcoming 13.2 about kernel management. The first use of these kernels was obviously for parallel computing, but we now have a unified system that also allows you to manage kernels for single evaluations and eventually also for front-end use in the same way. So I'll talk about remote connections and what you can do and cannot do, and some of the solutions with using modern remote access solutions. And then I give an overview over the tools that are currently available for configuring kernels. So superficially, not much has changed. You can still just launch local kernels, but the first argument here that's just a shorthand for 8 local kernels, but you can obviously also now specify URLs. That's the big improvement here, that this first argument has become a lot more useful. So here is a file URL, and the file obviously has to point to a local executable, and so here I'm using it for a single local evaluation, and that works like this. For SSH, there are a lot of changes under the hood. There's a new syntax where you use the SSH protocol. Here I do a single evaluation on a remote machine, access it through SSH. But I can, of course, also launch parallel kernels. So here I go to this machine and launch 64 kernels. And I can do a parallel evaluation here. All the process IDs, not very exciting, but I'm not going to talk about the use of these kernels, but focus on how you actually launch them. Now, a new capability is the new WSTPServer, which was introduced, I think, about a year ago. This is a server that listens for requests to make connections to kernels on the machine on which it is running. So I have a little Raspberry Pi on my desk, and it's running a WSTP server, and I ask it to launch 4 parallel kernels. Now, technically, this !4 is what's called a query argument. You see that sometimes in web pages when you fill out forms, but that's just a very convenient way to specify the number of kernels. So these are 4 kernels on that little machine, which has 4 cores. Lightweight grid is our technology for managing remote compute resources. It's similar to WSTPServer, but it predates it by, I don't know how much, at least 10, maybe 20 years. So the idea is similar. It's a different protocol, and you specify the machine name and the number of kernels you would like. Now, this is one of the reasons we want to replace this technology. It's rather slow. At that time, there was not much concern for launching dozens of kernels because there was simply no machines available that would actually be able to do that. Now, there's one feature that this lightweight grid technology has, which I would like to mention quickly. This, what you see here, is also in the documentation. There's a tutorial in 13.1 and 13.2 that tells you exactly how you discover these agents. So you can ask one of these machines, and all of these agents, they talk to each other and they always know what their neighbors are. And so you can ask for all the services that are there. So this now accesses those machines, and Then you can, for example, list the properties. So here you can see I should have, but I don't have a scroll bar somewhere. So this would allow you to see what's available and to choose one of the services. So I can say I use the fourth one and I want to launch 2 kernels. So all of these blobs have a plus sign which allows you to see some of the most important properties. So here the number of kernels, the agent, that's the address of the machine, and I can launch them in the same way as before. So there is currently no user interface for doing this discovery. So that's why I'm mentioning it here. The technology is still there, but at the moment it's a little bit hidden. So what is new in versions 13.1 and 13.2? Now, much of this technology is over 20 years old, and network architectures have changed quite a bit. 20 years ago, there was little concern for security and encryption and malicious users. But now, of course, we have to be very careful about what we allow to do. So firewalls, network address translations, private address space, and so on, virtual private networks. And that lightweight grid server, which for various reasons is no longer maintainable, and we have to replace it eventually. And the replacement is already there. It's the WSTPServer. So I took this as a chance to overhaul the whole system for specifying and launching kernels. So it now supports more technologies, is extensible, and it supports modern security features of SSH. It supports the new WSTPServer. And there's a new way of remembering your choices that replaces the old parallel tools settings that you find in the system settings. Now, the work is not quite complete. I'm aware of certain things that are missing. There's currently no user interface for this kernel configuration, although I would claim, and I'll show you later, that this is no longer that important because it's now much easier to specify it with a single URL, and you no longer need all of this elaborate point-and-click interface. There's another thing which we are still working on, and that is support for these cluster management systems. Of course, that has also changed quite a bit in the last 10 to 20 years. And so it's now much easier to add new ways of launching kernels. And we plan to do that one by one. And Grid Mathematica, as old as it is, it does have some nice features, in particular monitoring of the kernel usage and the deployment. And we want to add those features to our solution with WSTPServer, special Grid Mathematica edition that will offer you the same capabilities that lightweight grid offers. Now, there are quite a number of obstacles to overcome if you want to do computations on remote machines. Now, the architecture, the network architecture is of course very diverse. You have these managed cloud compute services. You have your ad hoc machines that sit around in your office or maybe your lab or classrooms. And they all have different access methods, different security requirements, and so on. So it is a bit challenging to do this, but fortunately enough, we now have better tools than we had 10 years ago. So the first obstacle is what's called network address translation. If you are in a hotel room, you probably have a private IP address. You can still access the internet, but nobody can access services on your machine because these services are all blocked. And the conclusion now is, of course, that all the connections must be in the same direction going out. That was not the case with the old launch kernels method, where you would issue an SSH connection to the outside, but then the kernels would try to connect back to your machine, and that is simply no longer possible. The next obstacle or opportunities is VPN, virtual private network. That is a technology you typically use to access company resources while traveling. And one consequence of this is that your machine will have more than one network interface. And so if you want to accept connections, you always have to decide which one to use. There's some logic in the underlying code in Mathematica, but that is simply not possible to come up with a correct interface. So again, it's better to have outgoing connections, then you will never run into this problem. Another issue is password prompts. If you do connections programmatically to launch kernels, then you cannot have password prompts. And if you make 100 connections for 100 kernels, you certainly do not want to type the same password 100 times. Of course, passwords are really an old technology. There are much better ways to secure resources, in particular PKI, private key infrastructure, or hardware security tokens. And another obstacle is the various operating systems that until very recently had very different ways of allowing or not allowing connection to them. Now, Windows now also has a standard SSH implementation, client and server. So now finally we can, with the same tool, have a way of accessing any remote resource, provided it has been configured to allow access. Now, the way this is supported in kernel configuration, if you create a kernel configuration and you give this operating system option, then you can see that it automatically chose a reasonable binary based on the knowledge of the remote operating system. So it now becomes much easier to make connections across different operating systems. So the main tool that we use is SSH, which has become very sophisticated, and it supports almost everything that we need for straightforward connection to remote machines and launching kernels. And there's also an exciting new player in the VPN world, virtual private networks, that I'll quickly mention, that also makes it easy to access your machines while traveling or otherwise out of the office. So SSH supports keys or certificates that replace passwords, and these can be managed automatically. Now, typically, the SSH key itself will be protected by a passphrase so that nobody can just steal it. So you would still be prompted for a password, but that problem can be solved. There are so-called SSH agents that cache passphrases that you've used, and you can even tie those agents to your login keyring so that whenever you log in, all your passwords from the last session are already open and you can use them. And there's another technology, connection sharing. If you open one connection to a remote machine, then any additional connection you make will use the already established secure connection, and you will not be prompted for additional passwords. So one way to solve the problem is just to make one connection to the remote machine, keep it open, and then do no kernel connections without additional password prompts. And the third and most important feature is that SSH allows to tunnel TCP connections. So when you make a connection to a remote machine, then the kernel you launch on the remote machine can then make a connection back to your local machine through the SSH tunnel. So it's encrypted and it avoids all the NAT and firewall problems. So this is really the most important new feature that happens automatically when you launch kernels. Obviously, you can disable it if it doesn't work for one reason, but normally you don't have to worry about this. Now, the other new development, which I was very surprised to see how easy it was to set up, is a new VPN tailscale that has gotten quite a bit of attention because it's the first VPN that really is easy to set up, because you don't really have to set up anything. You establish an account with Tailscale. You install Tailscale on your machines, the local machines and the remote ones you want to connect to. And then you already have connections. Now, normally, when you think of VPNs, you're thinking of accessing remote resources or your company, or protecting yourself against an insecure hotel network. But Tailscale also offers point-to-point connections. So you can make a connection from one machine to another machine and not to a whole network. And really, when I tried this first time, it was very easy to do. I have a Windows machine here at home that is on the inside network, so it's completely inaccessible from the outside. I installed Tailscale on it. Then I took my laptop, installed Tailscale, and that laptop is on the outside over a mobile phone connection or a hotel network. And then I started a WSTPServer on the Windows machine. And on the laptop, I simply do launch kernels with WSTP protocol, and I specify the Tailscale IP address of that machine. And a few seconds later, I had 4 running kernels on that machine. So this technology allows you to set up point-to-point links, and it's very smart. It gets across almost all firewalls and net and everything. So it's really amazingly easy to use. So I didn't have to mess with my firewall. I didn't have to do any setup. Just log in to Tailscale. I use my Google credentials for that. So I didn't even have to set up a new password. The other new technology that I've already mentioned is engine servers. We have the lightweight grid server that allows you to request kernels on a particular machine, and WSTPServer, it's modern replacement that in addition to the parallel subkernels, it also allows you to request single-use kernels, and in the future, and it also allows you to use kernels as notebook kernels. And so we have one solution for all of these different use cases. So now, how do you actually configure your kernels using any one of these new technologies? So the new syntax is a new data type kernel configuration that accepts various heuristic strings. It looks at this is a host name, so it will automatically use SSH as the protocol, and so it's very easy to use. And it is fully documented. These are all the properties of these SSH kernels. So you can see there are quite a number of arguments, most of which you never have to touch, but it's all available if you need extra arguments for the remote kernel. If you need the specify the remote binary, so you can specify any of these when specifying your kernels. The way to do this is as follows. Say, these are all the properties. And so I take my old configuration and I say I want 4 kernels, and I want to use a specific remote kernel binary. You can even use an existing configuration and just modify it, and the result is exactly the same. But it's even easier than that, because you can cram all of this information into the URL, so the SSH protocol, the host name, the path to your remote binary, and the number of kernels to use. So you can see it picked up all of this. It has kernel count 4. It specifies the binary. And when you do it like this, you don't even need this wrapper, so you can specify this URL directly in your launch kernel command. So most of the time, your kernel configurations will be URLs. And that is specifically useful for your default kernels. The default kernels are the kernels that you want to use for parallel computation if you don't use any specific ones. So once I set my default kernels, if I now do a launch kernels without argument, it will go through this list. You can see it is now working on group 2, 3, and quickly we hopefully will have all of these kernels. So now I have all of these kernels of different types. And another neat new feature is a kernel selector for parallel evaluate. Let's say I want to evaluate the machine name, but only on one kernel per machine. This is particularly useful when you want to install packlets or other resources. So you don't install the same resource on all. I mean, if you have a machine with 64 cores and you want to install a packlet, you don't need to do it 64 times, but only one time. Now, this particular variable default kernels is something you would most likely like to remember. So that uses the new, well, actually not that new, initialization feature of kernels. So you can say, you can set an initialization value for this variable. And I just set it to what I've used before. So I know this configuration works. So I want to remember it. So if I were to quit and restart my session, which I'm not going to do, so as not to upset the presentation, then this variable would again have this value next time. So this is how you can remember the settings. The Parallel Tools uses the same technology for its own settings. I can tell you a little secret here. Parallel $settings. That is all the settings of Parallel Tools itself. These you can still manage through the user interface. If you go to the settings in the menu in the front end, you will see an interface with buttons for these variables. Now, whenever you do persistent initialization, then one problem is you may forget about them, and then you suddenly wonder, well, where does this value come from? And so one important command to remember is you can remove initialization values. And once you do that, it is gone. And next time you start a session, it will revert to the default. And note in particular that it's a good idea to use the URL forms for the default, for the initializations. Now, the reason is that the kernel configuration wrapper would introduce a delay on kernel startup because it's referenced in the initialization. And so all the code would be loaded even if you don't need it later on. So it's best to use URL forms for initializations. Now here's a neat example that shows how all of this works together. So let me specify a server, and then I use remote evaluate for a single evaluation on this machine. I ask it for its number of cores, and then I can take the old configuration and update it to say I want this many kernels, and you can see here now I have this 64. And so if I now launch my kernels, then a few seconds later, I should have my 64 kernels up and running. So there's quite a bit of new stuff. There is new documentation. There are a couple of tutorials, and the main entry points in documentation is obviously launch kernels, kernel configuration, and default kernels reference pages, which will point you to additional documentation. So I understand there was a bit of a hiccup because I originally tried to support the old and the new system together, and that just didn't work. So I had to completely remove the old code. And so there was a little bit of maybe some confusion. But now I hope that, especially with 13.2, where again I've put a lot of work into polishing all of this, it should now be easier, and using the new technologies should make it much simpler for you to access remote resources anywhere in cloud compute services, in your local network, and so on. So that's all I have to say. Thank you for your attention. I think there's time for questions, if we can relay the questions to me.
But Roman, we still need the kernel configuration options for local kernels, for advanced configuration of local kernels, right?
I mean, you can, there was an example here. Let me see. I had an example of local kernels. Okay, I mean, you can specify the binary and the number of kernels with URL strings, right? Now,
Right.
yes, but there are, of course, additional. If I make, let's make a local configuration, and so now, so you see there are all these options, and if you need to specify one of those, then you still need the kernel configuration wrapper. But I should have done this a long time ago. There's of course nothing that prevents me from actually using any of these as additional, I think it's an ampersand, and I could say kernel arguments equals something, right?
Does that work now?
No, I thought of it too late to add it to 13.2. But in the future, I mean, there's nothing that would prevent me from doing that. And of course, it would be it wouldn't be case sensitive. And so with that idea, except if for very complicated values, right? I mean, here, okay, list values should work in URLs, you can encode it. But there may be certain values which you cannot easily specify because you would have to URL encode everything.
Right, right. Plus, there's the front end has its little completion of these little tokens that you can put in that automatically evaluate to, like the kernel path or something, right? I'm thinking about it. So we would have to figure out some way to apply those to this URL.
Mm-hmm.
I'm thinking about
if you do it programmatically, then there's nothing bad about using the kernel configuration wrapper. I think this idea is more if you have to type it yourself, then, and especially if you want to remember it persistently, then clearly using query arguments is a much better option.
Right. But so all we would need then is a way to sort of tell the front end to use, set default kernel kind of thing for one of these.
Yes, that should work. Yes.
All right. All right. Well, thank you.